Hey everyone, I'm Sajid and I'm so glad you're here. Today we're diving deep into the world of secure software development. We all rely on software every day, and it's more important than ever to make sure that software is built with security in mind from the ground up. Think about it. Our banking information, our personal data, our communication networks, they all depend on secure code. So, buckle up. Over the course of this video, we'll explore the essential steps you can take to build software that can withstand the ever-evolving landscape of cyber threats. Before you even write a single line of code, you need to understand what you're trying to protect, and from whom. This is where security requirements definition comes in. It's kind of like building a house. You wouldn't start constructing walls without a blueprint, right? Similarly, in software you need to define your security objectives early on. What are you trying to protect? Is it sensitive user data, financial transactions, or critical infrastructure? Once you know what you're defending, you need to figure out who might be trying to attack it. This is where threat modeling comes into play. Think of your worst enemies, but in the digital world. We're talking about identifying potential vulnerabilities and prioritizing risks. By understanding the threats you're facing, you can design your software to be as resilient as a fortress. Alright, so we've got our blueprints, we know our enemies, now it's time to lay the foundation for our secure software fortress. This is where secure design principles come into play. One key principle is least privilege, which basically means giving your software only the bare minimum permissions it needs to function. It's like giving your house keys to a house sitter. You wouldn't give them keys to every room, right? Then we have defense in depth. Imagine your software as a castle with multiple layers of walls. If one layer is breached, there are still others to protect the core. And let's not forget, fail securely. Even if something goes wrong, your software should be designed to fail in a way that doesn't compromise security. It's like having a backup generator. If the power goes out, you're still covered. Now we're getting to the nitty-gritty writing secure code. This is where you put on your coding ninja suit and fight off vulnerabilities with every line you write. Thankfully, there are tons of resources like the OWASP Top 10, CERT Secure Coding Standards, and SEI Guidelines. These are like your trusty coding manuals, packed with best practices and techniques to avoid common security pitfalls. Remember those nasty SQL injection vulnerabilities we talked about? Well, these standards will teach you how to sanitize your inputs and keep those pesky hackers at bay. And don't forget about buffer overflows. Learn how to write code that's as tight and secure as a drum. Even the best code ninjas need a second set of eyes. That's where code reviews come in. Think of it like having a coding buddy check your work for typos, logic errors, and of course security vulnerabilities. But hey, we live in the age of automation. So in addition to human reviews, we can leverage the power of static application security testing tools, or SAST tools for short. These tools are like automated code inspectors, scanning your code for potential security flaws without even running it. It's like having a super-powered spell checker for your code. Alright, we've designed our software securely, written clean code, and even had it reviewed. But how do we know it can withstand real-world attacks? That's where security testing comes in. It's like putting your software through the ringer. Dynamic Application Security Testing, or DAST, is like simulating real attacks on your running application. It helps you find vulnerabilities that might not be apparent just by looking at the code. Then there's fuzz testing, a technique for finding edge case vulnerabilities by throwing random data at your software. It's like stress testing your code to see if it cracks under pressure. And finally, we have penetration testing. This is where ethical hackers try to break into your system to identify weaknesses before the bad guys do. It's like hiring a security consultant to test your defenses. In today's world, we rely heavily on open source software. It's like borrowing tools from a shared toolbox, super convenient, but it also comes with risks. That's where dependency management comes in. It's all about keeping track of the open source components you're using and making sure they're not riddled with vulnerabilities. Think of it like checking the ingredients list on a food label. You want to make sure you're not accidentally adding something harmful to your software recipe. Thankfully, there are tools like OWASP Dependency Check and SNCC that can help you scan your dependencies for known vulnerabilities. It's like having a food safety inspector for your code base. We're in the home stretch now. We've built secure software, but how do we make sure it stays secure as we move it from development to production? That's where secure build and deployment practices come in. Think of it like transporting a valuable artifact. You wouldn't just throw it in the back of a truck, right? You'd use a secure armored vehicle. Continuous integration and continuous delivery or CI/CD pipelines are like those armored vehicles for your code. They automate the build and deployment process, but with security checks built in at every stage. It's like having security checkpoints along the way. Our software is out in the wild, but our job isn't done yet. Just like a watchful guardian, we need to continuously monitor and log its activity to detect and respond to any suspicious behavior. Think of it like having security cameras and motion detectors for your software. Logging gives you a record of what's happening, while monitoring allows you to spot anomalies in real time. And if something does go wrong, having detailed logs is like having a trail of breadcrumbs to help you investigate and fix the issue. It's like having a digital detective on call 24/7. Remember those vulnerabilities we talked about? Well, even with the best security practices, new ones are being discovered all the time. That's why patch management is crucial. It's like updating your antivirus software. You need to keep it up to date to protect yourself from the latest threats. When vulnerabilities are discovered, software vendors release patches to fix them. It's like getting a software upgrade that strengthens your defenses. The key is to apply these patches quickly and efficiently to minimize your exposure to attack. And there you have it. A crash course in secure software development. By following these steps, you can help ensure that your software is as secure as Fort Knox. Remember, building secure software isn't just about writing code, it's about having a security mindset at every stage of the development lifecycle. So go forth, build amazing things, and don't forget to hit the like and subscribe button for more information on secure software development.